Welcome to the Unitar video on the sustainable management of PCB contaminated sites. This video presents 5 phases of the sustainable management of PCB contaminated sites. The same approach is provided in the guidance on the best available techniques and best environmental practices for management of POPs contaminated sites of the Stockholm Convention. Let's explain first what a contaminated site is. A contaminated site is a site with contaminated soil and contaminated groundwater. Soil and groundwater contamination is often caused by spills of products like oil. In this example, the source of the contamination is a leaking oil tank causing soil contamination and a plume of contaminated groundwater emitting contaminants in the surface water. This contamination causes risks for human health and the ecosystem, and measures should be taken to eliminate, reduce, or contain these risks. Many man-made chemicals have contaminated our soils, and one of them is PCB, a persistent organic pollutant, or in short, POP. PCBs are called a probable carcinogen, and it is proven indirectly that they can cause cancer. People exposed directly to high levels of PCBs, either via the skin, by consumption, or in the air, have experienced irritation of the nose and lungs, skin irritation such as severe acne, chloracne, and rashes, and eye problems. PCBs have been used for a variety of industrial processes and purposes, including electrical transformers and capacitors, as heat exchange fluids, as paint additives, in carbonless copy paper, and in plastics. PCB contaminated sites are along the life cycle of PCBs from production to disposal, such as workshops where electrical equipment is serviced, sites where obsolete electrical equipment is stored, scrapyards and other facilities where PCB equipment are or were managed in end of life, and sites with leaking electrical equipment containing PCBs. PCB can also contaminate our soils by atmospheric depositions from secondary metal industries or by the dumping of rubble with PCB containing painted materials and sealants. This video focuses on the soil contamination caused by leakage of PCB oil and PCB containing oil from electrical equipment, the so-called closed applications, which is the most prevalent and relevant cause of PCB contamination in developing and transition economies. When soil is contaminated with PCBs, it can pose human health, ecological, and migration risks, also referred to as environmental risks. To cost-effectively control or eliminate these environmental risks, we best follow a stepwise approach. We therefore recognize the following 5 phases to sustainably manage these PCB contaminated sites, beginning with Phase 1, the preliminary site assessment. Then we have Phase 2, the site assessment, followed by Phase 3, the site remediation assessment, then Phase 4, site remediation management, and the last phase, Phase 5, the site monitoring and aftercare. Each of these phases, their objectives, and set of site-specific deliverables will be briefly explained in this video. We start with Phase 1, the preliminary site assessment. The objective of Phase 1 is to sketch the on-site contamination situation using only the available site information. To report this, we use the Initial Conceptual Site Model, ICSM, the first deliverable of Phase 1. The ICSM describes your understanding of the contamination site using as many figures, tables, and pictures as possible. The ICSM contains the suspected source or sources of the contamination, the potential pathways of the contaminants from source to receptor, and the potential receptors. The ICSM is then used to obtain the second deliverable of Phase 1, the preliminary risk assessment. The result of the risk assessment is your judgment of the environmental risks at the site. To give an example of a simple ICSM, in this picture, the 2 boys are at risk as they are directly exposed to DDT. The source is the item containing DDT. The pathway is the touching of the DDT by the boys, and the boys are the receptors. As Phase 1 is not costly, Multiple site Phase 1 campaigns can be used to select sites with the highest risks. Based on the results of the Phase 1, it may be necessary to implement emergency measures to reduce the highest risk. Emergency measures can vary from fencing and site use restriction to capping and installing a site drainage to prevent further spread of PCB contamination to the surroundings. The objective of Phase 2 is to fully understand the on-site contamination situation, including its environmental risks. As the ICSM from Phase 1 does not provide the complete picture of the site contamination, you must ask yourself what information is missing to understand the contamination situation completely. This process is called the gap analysis. To get the answers, a costly site survey must be carried out. For each survey, you sample the soil, the sediments, if present, and the groundwater, if it's not too deep. These samples are subjected to on-site screening by field tests and/or by laboratory analysis. The results of this survey is the Complete Conceptual Site Model, CSM. All sources and source receptor pathways are mapped, and the receptors are identified. With a complete CSM, Phase 2 concludes with the detailed risk assessment. This risk assessment rejects or confirms the potential risks assessed in the first phase. The deliverables of Phase 2 are thus a complete CSM and risk assessment provided in a survey report with all the survey data, like bore logs and analytical certificates, attached. When more than one site is subjected to Phase 2, the result of risk assessments can be used to prioritize high-risk sites depending on the funds available for remediation. When Phase 2 has proven that there are unacceptable risks and the site is selected as a high-risk site, Phase 3, the site remediation assessment, must be implemented. The objective of this phase is to select the best remedial option. The best option is the one that reduces most of the environmental risks with the best environmental merits, not entailing excessive cost. The remedial techniques for PCB contaminated sites used to design this option vary from restricted site use, for instance, excluding livestock, cattle, chicken, etc., since they are key exposure routes, to in situ biodegradation, to completely excavating the contaminated soil for off-site treatment. The results of this remediation assessment are reported in a remediation plan, the deliverable of this phase. A remediation plan includes a feasibility study, a cost estimate, and the term of reference of the best option. This phase is often executed by specialized consultancy firms. When the financing is secured, preferably by the polluter's pay principle, the next phase, the remediation itself, can be implemented. Once a contracting firm is contracted to carry out the remediation in conformity with the terms of reference, Phase 4, the site remediation management, starts. The objective of this phase is to control and/or remediate the environmental risks to acceptable levels. This phase comprises of the actual site remediation works often executed by a specialized contractor, and the supervision and monitoring of these works are often provided by an independent consultancy. Here, the PCB containing waste and oil was packed and temporarily stored, awaiting final disposal. The PCB contaminated soil was excavated, loaded, and brought to a soil treatment facility. After the remediation works are completed, very often there are remaining risks caused by, for instance, groundwater contamination. Such sites need monitoring and aftercare, Phase 5, of the sustainable management of PCB contaminated sites. In this example, monitoring and aftercare were needed for years to see if the installations prevented off-site migration. The sustainable management of PCB contaminated sites needs an assessment of PCB pollution along the life cycle of PCBs and PCB-containing equipment. Site assessment and remediation is often costly and a time-consuming operation. Following the 5 phases will create the opportunity to cost-effectively control the environmental risks from a PCB-contaminated site. This will result in healthy soil, which is the basis for a healthy society.